Hi everybody, in this video, let's look at 8.1 vectors. In PT3, you already learned about the vector quantity and scalar quantity, right? Let's do a quick revision. A scalar quantity is a quantity that only has magnitudes. For example, area, volume, mass, distance, and so on. Okay, let me add one more here, speed. For a vector quantity, it's a quantity that has magnitudes and direction. For example, force, weight, displacement, velocity, and so on. So let's look at this speed and velocity. This is scalar quantity, only consists of magnitudes. This is vector quantity, consists of magnitude and direction. Let's say we have two particles. This is particle A. Move this way from left to right, and then we have another particle called B. Move this way. Okay, now I want to state their speed and velocity. Okay, this one, let me use blue color. Speed. Okay, so this one, velocity. If let's say the particle A, every single second, particle A move for 10 meters to the right. So the speed will be 10 meters per second, right? Every single second, it moves 10 meters. Now we have a particle B move in the opposite directions. Same thing, every single second move 10 meters. So the speed will be the same, 10 meters per second. But when we come to velocity, then they are different, because velocity is a vector quantity. It has magnitudes, how fast is it, and it also has directions. Okay, so the velocity for particle A will be still the same, 10 meters per second. We don't have to write the positive. People know that if we do not write anything here, people know that this is positive. Normally, to the right hand side, we will use positive. To the left hand side, we will use negative. So now, they move in the same speed, right? 10 meters per second, but different directions. Particle A move from left to right, moving to the right hand side, and particle B moving to the left hand side, opposite direction. So the velocity is no longer 10 meters per second, but we have to add a negative sign to indicate that they are in opposite directions. Okay, so these are differences between speed and velocity. Speed is a scalar quantity, velocity is a vector quantity. So these are the few ways that we can use to represent vectors and also its magnitudes. So normally, if we write by our hand, we will choose this way or this way. Write a small letters and put a tilde sign underneath the small letters. So if you want to write two letters to tell people that from A go to B, then we write A first, followed by B, and put an arrow on the top pointing this way. So people know that it's from A to B. So these are the few ways to represent the magnitudes of the vectors. Okay, now let's look at number 4. A negative sign is used to denote the vectors in the opposite directions. Okay, when you see a negative sign, right, it means that opposite direction. Same thing like this one. So now you look at these two vectors, A to B, this is B to A, but they have the same length, same magnitudes. What is a different thing is you look at the arrow. So in vectors, you have to look carefully the arrow. The directions of the arrow is very important. So this go this way, and this go this way, right? Opposite directions. If this is A, then this will be negative A. If this is negative A, then this will be A. Okay? So here still have some more some note over here. This one I will skip first. So later on, if I need this one, I will go back to this. Let's look at few example first. Okay, let's look at this example number 1. Draw and label each of the following vectors. So P, Q. So it means that from P to Q with a magnitude of 6 units and to the west. You see, vector we not only has the magnitude, how many units, but we also have the directions. So this vector is to the west. So I hope that you still remember this one. This is north, this is east, south and west, right? Okay, now P to Q, magnitude 6 units to the west. So we need to draw, how to draw? We draw this way, right? This way. So I don't have a ruler over here, so maybe I cannot not able to draw a very straight line. Okay, I try my best. So 1, 2, 3, let me pause the video first and draw a straight line to show you this vector. Okay, so now we have a vectors. How many units? Let me calculate correct. 1, 2, 3, 4, 5, 6. Okay, so now we have drawn a line with the 6 unit magnitudes. But don't forget, we have directions. Go this way, right? West, this way. So we have to put an arrow over here. So this is P and this is Q. So this is the way how we draw a vectors. We have the magnitudes and also the directions. So be careful of this arrow. If you point this way, it's not correct. Okay, now how about this one? Vectors R. So this is another way we can use to represent vectors. Put a small letters and put a tailor underneath the small letters. With magnitudes, we have the magnitudes given here. 4 times square root 2 units and southeast. Okay, let me draw again this direction for you. So this is to the north, this is east, this is south, this is west. Southeast, it means that go this way, 45 degrees over here. Okay, but how to draw this one? Let me calculate the unit for this one small grid, the diagonal, let's say. Now this one we call it diagonal, right? Okay, from the vertex, from this vertex to this vertex. So what is how many unit over here? So you look at this is one. Okay, how about I use this one, easier. This is 1 unit, this is 1 unit. Now we have a triangle over here, right? Here's 1. So if I want to find the distance here, how many units over here? Use Pythagorean theorem. 1 square plus 1 square square root. So it will be square root of 2. So it means that one of this one diagonal, this is square root of 2. So if I draw 2, then it will be 2 times square root of 2. If I draw 3, it will be 3 times square root of 2. Okay? So now we need 4. So where to start is up to you. Want to start here or start here is okay, as long as the direction is correct. Okay, so now let me draw this vector first. So how about I use this one? Straight line, draw easier. So how about we start from here? So I need 4. For 1. Oh, so this is a little bit hard. Okay, hold on, let me pause the video first. Okay, here we go. Now this is R, right? Okay, so be careful. Now we have the magnitudes 4 times square root 2 units. We have 1, 2, 3, 4. Now we are going to assign an arrow over here to the southeast, so we need to point this way. Okay, then this is vector R. Put an R, put in tailor sign underneath this small letters. Okay, let me check or not. 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so this is the way how we draw these vectors. So remember the directions. The arrow is very important. Okay, let's try an example. Determine the directions and the magnitudes of the following vectors, and state the directions and magnitudes of the vectors. Okay, so now we need to answer two things. The direction, the directions of the vectors and also the magnitudes. So now this is, okay, look carefully the arrow. This arrow is pointing upward, right? Pointing this way. So this is to the north. So let me give you the direction first. The directions of PR, sorry, not PR, PQ. PQ is to the north. Okay. Okay, now we are going to state the magnitudes. So still remember, how do we represent the magnitudes of a vector? This is PQ, right? So we write PQ first and put this sign. So now this means that the magnitudes of the vector PQ. How many units? 1, 2, 3, 4, 5, 6. 6 units. Okay, so let's try this one. Look carefully, the arrow is going this way. So this is 45 degree, right? 45 degree. So it means that this direction go this way. So this is northeast. The direction of V, this vector V, is to the northeast. Okay, so now we are going to state the magnitudes of this vector. Okay, so how many units? Still remember just now I told you this is square root 2 unit, right? So we have how many? 1, 2, 3, 4, 5, 6. 6. 2 units. Okay. So not necessarily every time it's square root 2 unit. You have to look at this. Sometimes it's 2 unit, 2 units. So this is 1 unit, 1 unit. So how do we get square root 2 unit? Because we use Pythagorean theorem, right? 1, 1. So here will be square root 2. So if this is 2, 2, then we need to calculate again. Okay, let me show you here. Let's say if I have a small grid like this, this is 2 units. Then how about what's the length here? The length here will be 2 square plus 2 square root. 24 square root 8. Okay, so this one you can change become 2 okay, 2 square root 2. But in this case it's not 2 square root 2 because this is 1 1, not 2 2. Okay, so let's try few more example. Okay, now we have a vectors over here. This is directions and magnitudes. We look at the arrow. Arrow is pointing this way, go downward like this. So this is vector P. So given the vector P as shown in the diagram, draw the vectors for -1 over 2 P and 3 over 2 P. When we see the negative sign, right? Definitely we know it will be in the opposite direction. Okay, so this is P, this is, okay, now we ignore about the negative first. Ignore about negative. We just look at 1 over 2P. It means half of this. Half of this. So now I have copied this one over here. So easier for us to compare later on we want to draw. So it means that you just want to draw half of this. So this is, or you can use use a small triangle to help you. This is 2, 4. So if you want to draw half of it, then it will become 1, 2, right? Okay, let me draw over here. 1, 2. Okay, 1, 1, 2. This way. Oops. So it's a little bit hard to draw a straight line over here. Now I might just assume that it's straight. 1, 2, 1, 2. Okay, but in the exam you have to draw using a ruler. Okay, so now this is 1 over 2p, but we haven't completed yet. This is not the final answer. 1 over 2p. Since this is negative, so we need to show the arrow in opposite directions. This is going this way. Since this is negative, we need to go upward like this. Okay, so this is negative 1 over 2p. So this is the way how we draw this given vectors. So how about this? Okay, you don't see any negative sign here. It means that same directions. So this vector and this vector, they are parallel. They are parallel, just in different directions. They are parallel, and magnitude will be different because this is longer, this is shorter. They have different magnitude, but they are parallel to each other. So how about this one? Same thing. So now I'm going to draw a line which is parallel to this one, but this is longer because this is 1.5, right? 3 over 2 is 1.5. 1.5 times of this, so it will become longer. So you can use a triangle to help you as well. So this is 2, right? This is 1, 2, 3, 4. This is 4. So since I want 1.5 times, I times 1.5 times 1.5. So here you will get 2 times 1.5, you will get 3. 4, okay, this is 4. Can you see it? This is 4. 4 times 1.5 will be 6. Now I'm going to draw this line, this vector. So let me use a triangle to help me. So I go down 3 units, go here 6 units. Okay, how about I start from here? 1, 2, 3, 4. Oops, I just need 3. 1, 2, 3. Okay, go this way. 1, 2, 3, 4, 5, 6. Okay, stop here. Now I'm going to draw a line from here. Oh, this one sometimes a little bit hard to draw. Okay, let me change it, see whether I can do it or not. Drawing. Okay, so try to move it. Try to draw as accurate as I can. Oh, it's not really. Okay, let me try again. Okay, this one better. So now let me check correct or not. So do you notice that they have the same gradient parallel to each other? Okay, now I'm going to show the I'm going to assign the arrow on this vector. Same direction because we don't have a negative sign, so same directions with this one pointing downward like this. Okay, so this is 3 over 2p. Okay, let me double check. Sometimes I'm quite careless. So this is 3, this is 1, 2, 3, 4, 5, 6. Okay, correct. Okay, so this is the way how we draw a vector. Okay, let's try these 2 example. Okay, before this, let me go back to this to show you some notes here so that easier for you to understand what I'm doing. The product of a vectors Q, vector A with a scalar K, we mean Ka. So this vectors is a product of a K and A, right? So it means that the magnitude of this vector is actually K times of the magnitudes of these vectors. So K positive, it means same directions as I told you just now. K negative, it means that opposite direction. Okay, let's go through this note first. 2 vector A and B are equal if and only if they have the same directions and same magnitudes and same direction. If they are parallel, so A is equal to KB. So let's say if I give you 2 vectors, I can write in this form: A equal to KB. So you know that these 2 vectors, if let's say the A and B are non-zero vectors, so you still write at this, it means that they are parallel to each other. Okay, look at this. 2 vectors A and B are parallel if one vector is a scalar multiples of the others. So K times B, so this is a scalar multiples. Okay, K is a constant. So if the K here is positive, it means that A and B same directions. If the K here is negative, it means that K and B different directions, opposite direction. Okay? So now, if 3 points A, B, C are collinear, so look at this one. A, B, K, B, C. As I told you just now, if you write like this, and A, B, and B, C are non-zero vectors, if you write like this, it means that A, B, and B, C, they are parallel, right? They are parallel. So, but do you notice that there is a common point? It means that they actually fall on the same straight line. They have the same gradient, and they have a common point. It means that A, B, and B, C, they are connected together. So it's collinear. So every time the question asks you to prove they are collinear, first you write in this form first. Once you write in this form, you can say they are parallel. And the next thing is to mention the common point. Okay? Now let's go to the last one. Okay, how about this one? I skip first. Later on, I go back this. Okay, let's try some question first. Okay, wait for a while, still loading. Okay, let's try this too. Given PQ is equal to 2V and AB is equal to negative 3 over 5V, determine whether the vector PQ and AB are parallel. So still remember what I told you just now. If you can write PQ equal to what? Something times KB? PQ equal to something times AB, or AB equal to something times PQ, that means they are parallel. Okay, so how about I express this one? PQ is equal to 2V, right? So V will be equal to, I move the 2 over here, it becomes PQ over 2. Okay, so now let me copy this one. AB is equal to negative 3 over 5V. Okay, so now I substitute this whole thing into here, because this is V, right? V is equal to this. I am going to take this one, substitute over here. So AB is equal to negative 3 over 5. That's PQ over 2. Oh, sorry. Let me move it. Okay. Negative 3 over 10 PQ. So this is AB. Okay, from here, what information that you can get? You know that they are actually opposite direction, right? Opposite direction. And now, since we already write this one, AB is equal to a constant times PQ, scalar multiples. So we can say that, therefore, AB is parallel to PQ. If you don't want, you can say therefore AB and PQ are parallel to each other. Okay, so negative, what can you get from here? Negative, it means that different directions. Okay, AB and PQ different direction. So if I ask you, AB, the magnitude is longer, bigger, or PQ? So if you feel hard to determine which magnitudes, let me think how to say, which vector having a greater magnitudes. So you can do this way. Some students can get it directly here. So you know that actually the PQ is actually longer, right? If you want to draw it. So if you cannot see it, you can draw it this way. Now you move the PQ over here, PQ, then you will get. So if this AB is 3 part, PQ is 10 part, right? So it means that PQ is actually longer. But this question does not ask you to do this. It just wants you to show that, to determine that whether they are parallel or not. So this was just extra information. So if you see negative, different directions. So if you want to know which one is longer or which one is largest, so you can do it this way. So easier for to see. So from here, very easy. AB 3 part, PQ 10 part. And you see a negative sign, it means that opposite direction. Okay? Now, let's try this one. Given MN, okay, here should have a line over here. So I don't know why when I convert it to PDF, this line is disappearing. Okay. So now I have Mn is equal to 4U, Np is equal to 7U. We want to show that M and P are collinear. So still remember what I told you just now. First thing, you want to write in this form first. Then you can say that they are parallel. The next thing, look for the common point. Okay, let me do it this way. Mn is equal to 4U. Let me copy first. Np is equal to 7U. How about I do it this way? Mn over 4 is equal to U, right? So now I'm going to move this whole thing U over here. So Np is equal to 7U. Np, okay, so it's 7 over 4 Mn, Mn, let me write again, Mn. Okay, so from here we can say that therefore Np, okay, Np and Mn are parallel, Okay, so next thing, since the question not only asks us to show they are parallel, but they want us to show collinear. So we need to look at common point. Since we have a common point which is N, okay, since N is a common point, so okay, I continue over here. So point M, N, and P are collinear. Okay, my spelling correct or not? Okay, collinear. Okay, so this is a way how we shows the given point are collinear. So let's try to observe this one. So if I ask you NP and MN, it's that same direction? Yes, because this is positive, right? You know same directions. Okay, so if I ask you which one is longer, NP or MN, you know this is NP, right? How we know? You can look from here, or you can do it this way. You move the MN, go down this way, MN. Okay, this is 7 and 4, right? NP 7 part, MN 4 part. So we know that NP is actually longer. Okay, let's try one more question. Okay, so this is the last question that I'm going to discuss with you in this video. Before I show you how to do it, let's go back to my note. Oh, wait for a while. Okay, let's try this one. If the vectors A and B are not parallel, HA and KB will only exist when, okay, if they are not parallel, actually we cannot write like this. But if you insist to write like this, there are two conditions. First thing, will only exist when both vectors A and B are zero vector. If they are zero vector, then you can write like this, even though they are not parallel. And the second condition is the coefficients H and K, they are equal to 0. So let me give you the concept something like this. Let's say 3 is equal to 5. This is not correct, right? 3 is not equal to 5. But if I take 0 times 3 and 0 times 5, then they will become 0. So they become equal. So it's the same almost the same concept for this one. Okay? Now, if you understand this one, then it will be easy for you to solve this question. Vector P and Q, non-parallel. Okay, non-parallel and non-zero vectors. So if this is non-parallel, if they are non-parallel and they are non-zero vectors, we actually cannot write like this, right? So if you still want to write this, it means this is 0, this is 0. Okay? So if you still cannot understand, you can pause the video and go back to the note just I show you one. Try to think a little bit. So once you understand, then only you try this one. Okay? Now, non-parallel, non-zero, we cannot write like this. If you want to write like this, it means the front here, the coefficients of P and Q definitely will be equal to 0. So from here we know 2n minus 4n plus 1 is equal to 0. Negative, okay, let me copy first. Negative 4m minus 6n minus 3 is equal to 0. Okay, so now what do we need to do it? We need to find the value of m and n. So let me write this way first. It's equal to 3. So this one 2m minus 4n is equal to negative 1. Oh, negative 1. This is too long, the negative. Negative 1. Okay, let's be the first equation and the second equation. So if you want to make sure that if you worry that you will make mistake over here, this is simultaneous linear equation, you can use your calculator to help you to check the answer first. So now I'm going to take this one times 2. I want to eliminate the m first. So why I times 2? Because I want to eliminate the m, right? So this is 2, this is 4, negative 4. So I want to change this one become 4. That's why I times 2. I take the first one times 2. Then this will become 4m. This will become negative 8n. And this will become negative 2. So this is the third equation. So now we have 4m over here. Negative 4m. This is 4m. I can eliminate the unknown m easily. So I just take the second equation plus the third equation. So negative 4 plus 4, it becomes 0. So we have successfully eliminated the m. This one plus this one, you get negative 14n. This one plus this one, oh, correct or not? Should be correct. Let me check later. So n is equal to 1 over negative 1 over 14. Okay, let me check my answer. Correct or not? N is equal to negative 1 over 14. Yes, correct. Okay, so if you have used a calculator to check the answer just now, you can compare this answer with the answer that you got from the calculator. If it's different, then continue. Maybe some mistake over here, try to double check again. If this is correct, same with the answer given by your calculator, then only you continue and you just be more careful. Should be no problem to get the value of m correctly. Okay, now I'm going to use this value, substitute into the first one. Substitute n equal to negative 1 over 14 into the first one. If you don't want to choose the first one, you can use the second one. So 2m minus 4n. Now I don't want to write the n anymore because I know that n is equal to this, right? Negative 1 over 14 equal to negative 1. Okay, so this is simple linear equation. I think it should be no problem. Negative, negative, it become positive. 4 times 1 over 14, it will become 24. Okay. Correct or not? Should be correct. Okay, let me continue. Negative 1 minus 2 over 7. This one you can use a calculator to help you. Okay, so m is equal to negative 9 over 7 divided by 2. Divided by 2, it means times 1 over 2, right? M is equal to negative 9 over 14. Let me check my answers. Negative 9 over 14. Okay, correct. So for this video, I stop here first. Hopefully you understand better about this subtopic after watching my videos. And thanks a lot for watching. See you next time. Bye bye.